In the next section of chapter 6, we're going to be focusing in on the white blood cells. They're derived from red bone marrow. And if you'll remember in the last set of notes, we talked about this idea that the red bone marrow produces these stem cells, some of which create platelets, some create red blood cells. We're going to be talking about the white blood cells. These are large blood cells. They do have a nucleus. Their production is regulated by colony stimulating factor, or CSF. They can be found in the tissues as well as the blood, and their key goal is to fight infection, and they're a really important part of your immune system. Some only live for a few days, while others can live for months or even years. If you look at these different white blood cells, you'll notice they're broken down into granular leukocytes. Leuko means white, cyte means cell. So here's your granular leukocytes. See how they kind of have a grainy appearance to them? And your agranular leukocytes, which are your lymphocytes and monocytes. Notice that they look a lot smoother. Also notice in your granular leukocytes that they have multiple nuclei. See how they kind of look like they have more than one nucleus? Whereas in your agranular leukocytes, it looks like they just have one nucleus. The neutrophils primarily eat pathogens and cellular debris. They just go through the bloodstream finding pathogens, debris, and they just ingest that. The eosinophils also digest large pathogens, but they focus more on things like worms, and they reduce inflammation. So worms, we're talking like bigger parasites. The basophils promote blood flow to injured tissues, and they trigger that inflammatory response. So if you've got a cut that's gotten some dirt in it, these are the cells that are going to start triggering that inflammation, that delivery of more blood. It gets hot, that dilation of the capillaries there. If you look at the agranular leukocytes, we have the lymphocytes. These are responsible for specific immunity. These are your B cells and your T cells. These are what make your antibodies to fight specific diseases. So when we talk about getting a vaccine that produces antibodies to fight disease, that's what we're talking about. This is what gives you your immunity. The monocytes become macrophages that eat those pathogens and cellular debris, but they're also more specific. So if you think about this is kind of a general defense. They just go after anything and everything that looks bad. These are going to go directly after something very specific. So if you've had chicken pox or had the vaccine for chicken pox, you now have antibodies to fight it. So if you are exposed to chicken pox again, this is the system that's going to be engaged to try to fight that disease off. So again, here we're looking at those granular leukocytes, which have the noticeable granules. They have those lobed nuclei, whereas the agranular leukocytes have no granules and no lobed nuclei. The neutrophils take up about 50 to 70% of all white blood cells. Notice that kind of almost looks like they have 3 nuclei. And upon infection, they move out of the circulation and into the tissues to engulf pathogens. So this would be like if you have a cut that is in your finger, you're going to move those to that location. Eosinophils are a pretty small percentage of the white blood cells. They have 2 lobes in their nucleus, and many large granules function in parasitic infections. And they also kind of play a role in allergies. Your basophils, they're a little bit more rare. They have a U-shaped nucleus, and they release histamine, which is related to your allergic reactions. So when you take an antihistamine, it's working against that histamine. Histamine does things like inflame your nose, make you have snot, makes your eyes water, makes your lungs feel itchy. Then we get to your lymphocyte. This is about 25 to 35% of all your white blood cells. They have a large nucleus and take up most of the cytoplasm. They develop into your B and T cells, and those are really important in your immune response. And then your monocytes, relatively uncommon. They're the largest of the white blood cells. They have a horseshoe-shaped nucleus, and they take residence in your tissues and develop into the macrophages. And these are used to engulf pathogens. So if you look, these white blood cells can actually leave the circulation. You can see where we've had the triggered reaction, and those little tiny spaces between the individual cells and the capillary, they are oozing themselves through. So let's talk a little bit about some of the disorders that involve white blood cells. You can get severe combined immunodeficiency disease. It's inherited, and it's where the stem cells of white blood cells lack the enzyme that allows them to fight infection. You basically end up with someone who has no immune system whatsoever. Leukemia is a type of cancer, but it's specific to white blood cells. Basically, cancer is when you have blood cells growing out of control and unchecked. In leukemia, it's specifically the white blood cells that are growing unchecked. Another one is infectious mononucleosis, the kissing disease. It occurs when the Epstein-Barr virus infects your white blood cells. And if you've ever had mono, it is miserable. It causes you to feel really tired, have an awful sore throat, horribly swollen lymph nodes. It takes a very long time to get over it. And in some people, they will have lasting impacts from it for the rest of their lives. The second piece that we wanted to talk about in this section is the platelets. So what happens if you get a cut? How do you keep from bleeding to death? And so platelets come into play here. They're the result from the fragmentation of large cells called megakaryocytes in the red bone marrow. There's about 200 billion platelets that are made each day, and they function in blood clotting. Blood proteins named thrombin and fibrinogen, and if you recall back when we talked about proteins in the bloodstream, fibrinogen was one of those, create clots. They basically form these threaded fragments that catch the red blood cells and cause them to clump up. So here you can see an image of that. We get a blood vessel that's punctured. The platelets congregate and form this little plug. Then it causes this chain reaction that creates this thread-like structure, these fibrin threads, which act almost like a net, causing white and red blood cells to get captured here, creating that clot. So you can see that clotting up here. What it's not showing you is those threads happening from this chain reaction. There are some disorders that occur from platelets. Thrombocytopenia is a disorder in which the number of platelets is too low because enough just isn't made in the bone marrow, or the increased breakdown outside the bone marrow. So this would be someone who bleeds very easily. You can have a thromboembolism, and this is when a clot forms, which a clot in a little spot, maybe in your leg, isn't a big deal. But if it breaks off, it can plug a really important vessel. It can happen in like one of your coronary arteries or in the brain. And this is where you end up having someone pass away from it or have extreme damage from it. The last one is hemophilia, which is a genetic disorder that results in deficiency of the clotting factor. They just flat out don't make it. So when someone has a small bruise or a little tiny cut, they actually never form a clot. And so you get massive bleeding from something that would normally be pretty small. So in conclusion, this section, we talked about the white blood cells, what their function is in defending against disease, and then how you form blood clots.